Before the internet, if you needed to send something important, a contract, a signed document, a parcel, you would use a registered post system. You get a tracking number and a confirmation when it has arrived at the destination. And if it does not arrive, it will get resent. But if you were dropping leaflets through the door, you don't care if every single one of them landed or even if it was received at all. You cared about getting those packets out fast. That simple explanation right here is the concept of TCP versus UDP. And once that analogy clicks, the rest falls into place for you. This is why this matters. Every time you load a web page, you stream a video, you fire a DNS query, or you play an online game, a protocol design decision has been made about how that data gets sent to you. TCP and UDP aren't just exam questions, right? They are the reason your live stream doesn't freeze to resend a drop packet and why your file download doesn't arrive corrupted. So take TCP like this. It is the registered post. TCP stands for Transmission Control Protocol. It's the reliable option. Before any data is sent, TCP does what is called a handshake, okay, a three-way handshake. Your device sends a SYN, I want to connect to you. The server replies, SYN acknowledge, which means I have received your request, and then confirms the acknowledgement. So SYN gets sent, SYN is acknowledged, and SYN acknowledgement is also confirmed. That is simply TCP for you. So from that point on, every packet that is sent across the wire is tracked. If one goes missing, it will get resent. If they arrive out of order, they will get reassembled correctly. So TCP is used for things like HTTP and HTTPS web browsing, emails, file transfer via FTP and SFTP, anything where data integrity really matters. And there's a trade-off, right? Overhead. That tracking, acknowledgement, and potential resending will add latency. For most use cases, that is pretty fine. But for some applications, that latency is a killer, okay? Then that is where UDP really comes in. It's a leaflet drop scenario. UDP stands for User Datagram Protocol. There's no handshake, no acknowledgement, no resending. It doesn't care if the recipient is home or not. You will send the packet. It either arrives or it doesn't. You don't wait to find out. You drop it and you're gone. That sounds unreliable. And it is, yeah? But sometimes unreliability in sending stuff is really what you want, depending on your use cases, right? Think about live video streaming. If a packet from 10 seconds ago gets lost, you don't want to stream to pause and wait for it to be resent. That frame is gone forever. You move on. A brief glitch is better than a frozen screen. UDP is used for things like live video and audio streaming. That is why sometimes your stream gets and then just jumps to the next one. Online gaming, DNS queries, fast lookups is really what we need. Retry if it's needed. VoIP, voice over internet protocol. That is why sometimes if your person on the other side's internet is bad, they will sound robotic because frames and packets are dropping. Now you get the gist. The gotcha here is reliability is application layer. Modern apps built on UDP don't just accept packet loss. Protocols like QUIC, which powers HTTP 3, are built on UDP, but they add their own reliability and congestion control at the application layer. So you get the speed of UDP without the fragility. This is worth knowing. The line between TCP and UDP is blurring in the modern era of software development at the protocol level. But if the core trade-off, reliability versus speed, is still the mental model that you need. And I'm going to tell you a real life tool here that is used for testing TCP and UDP in action. If you want to see TCP and UDP real life in action, Wireshark is your best friend. Download it, open it up, and run a DNS query, and you'll see UDP packets. No handshake, just fire and forget. Load the web page and you see the TCP three-way handshake play out in real life time, just like you're watching a live stream, but here in an application. That's when it stops being a theory to you. So what should you do next right now? If you're building your DevOps skills or want a structured path, reply DevOps in the comments and I'll share with you the DevOps career mode map I share with most engineers that are just getting started in this field. If you've used Wireshark also to debug a network issue, drop it in the comments and I'll genuinely like to hear what you found out. I'll see you again in the next video. Cheers and goodbye.